Hi guys, let's have an introduction about Linux. So basically, Linux was created by Linux Torvalds during his college days. He was very frustrated by the native OSs which was running at that point of time. So he was like, he did whatever other people will do, like he created his own OS. So now, but initially it was started as a just as like a college project of his. Now it is like running in different architectures regarding ARM, x86, PowerPC, Spark, etc. It also runs in systems from Watch to supercomputers. Linux is still a Unix-like, but not exactly Unix. It borrows many concepts from Unix, but it is not a descendant of Unix. So it is also licensed under GNU General Public License version 2.0. So let's have an overview of an OS before going further. So mainly the major component of an OS is actually kernel. Kernel is like a core of an OS. So the components include interrupt handlers, which is used to service the interrupt request, and schedulers. Shared the memory among the different processes, shared memory, and also the processor. Sorry about that slide. And memory management system is actually manages the memory for process and system services. So basically, kernel typically resides in kernel space, and user application resides in user space. Kernel has full access of hardware and also has a protected memory. So basically, kernel space is like more like a elevator state of execution. So it is always it will be running in a kernel will be executing in a kernel mode. Applications running on a system can only access the hardware or do anything with the hardware where through system calls. So system calls is like kernel will do on behalf of the application whatever the request sent by the application. For example, printf. Printf is a most prominent statement in C language. So this printf is internally calling write, which is a system call, which will write to the console. Okay. So this is a small diagram which I got it from the internet. You can just is very self-explanatory. You can see that this is the what you can say the Linux architecture, kind of like we can say like that, a more very simplistic manner. Okay. So always there will be some architecture dependent kernel code. Okay. And also you can see the system call interface. Okay. And also the GNU C library. You can see here. Okay. So other components of the Linux are this device drivers, bootloader, command shell, basic file and system utilities. These things we will I will share in the later part of the videos. Not now, but the later sessions. So let's have a look at different types of kernel. One is like monolithic, and another is microkernel. Monolithic is like is implemented like an entire single process running in one single address space. All the kernel services executes in a large kernel address space. So the advantage of this monolithic is actually there is no complexity. It's very simple. But microkernel is in a different way. It is like the function of kernel is broken down into separate process called servers. So each of the servers will communicate to each other using some IPC mechanisms. And the advantage of microkernel is that if one server is down, suppose something in one server, something if the network server is down, okay, network functionality will not work. That's the only effect. But the entire system will not crash. But in case of monolithic, if something happens, the entire system crashes. So that is the difference between microkernel and monolithic. So Linux, as you know, is a monolithic type kernel, and this Windows, Mac OS, etc. are microkernels. So Linux has the advantage of microkernels also because the Linux supports this kernel preemption and also the dynamic loading of kernel modules. That means KO modules. We can come across in the later sessions. So Linux kernel versioning is done like with three numbers. That means, for example, 5.11, 5.12. Here, the major version is indicated by the first two numbers. That means 5.15 as taken as a whole. So the next version, it is like a stable candidate. So when the time frame is open for development for the next major, this RCN suffix is added. RCN means release candidate N. So N can vary from 1 to 7. So once the stable release is made, this maintenance is passed on to the stable team, and then the updates are done. You can see as written in there. If once the stable release is made, it is then termed as 4.13.1, 4.13.2, like that. So here in this case, it is 5.15.12. Okay. Thank you guys. Thank you guys. This is for this session.